Good morning all of you. Hope all are doing well. In the previous classes, we learned what is set definition and set notation, and then after that how to represent sets in three different methods. That means in description method, how to represent in description method, how to represent in roster method, then after that how to represent in set builder form also we learned. And some problems also we solved on these three representation methods and the basics of sets. And in today's class we are going to learn different types of sets. The first in types of sets, finite set. Finite set. If number of elements in a set are countable, if number of elements in a set are countable, then that set is called finite set. For example, vowels in English alphabet. A is a set of vowels in English alphabet. Means A, E, I, O, U. A, E, I, O, U. Now how many elements are there? 5. Means it is countable. Here easily we can count how many are there. I am telling 5. If so, such type of set is called finite set. And the next one, infinite set. If number of elements in a set are uncountable, then that type of set is called infinite set. For example, B is a set of natural numbers. That means 1, 2, 3 and so on. We know natural numbers are infinite. We cannot count all natural numbers. How many means still question mark. How many we cannot tell. We cannot tell means that is infinite set. That means if number of elements in a set are uncountable, then that set is called infinite set. Countable means finite set. Uncountable means infinite set. The next one. Equal set. Equal sets. Take any two sets. If elements in those two sets are same, then those two sets are said to be as equal sets. That means, take set A, elements I am taking as 2, 3, 5, 7. In set B, 7, 5, 2, 3. Now what are the elements in set A? Are the same elements set B also having. Order is differs, no problem, but elements are same. If the elements are same in the two sets, then those two sets are said to be as equal sets. And the next one is equivalent. Equivalent sets. Here equal sets means just we will represent this equal sets as is equal symbol. Equal symbol, that means A is equals to B. Then after that equivalent. Equivalent means if number of elements in two sets are same. Take two sets, any two sets. Set A and set B. is a set which contains elements as vowels in English alphabet. And now set B is a set which contains first 5 prime numbers. First 5 prime numbers. Now observe these two sets. Here the elements are different. Different elements. Elements differs, but number of elements are same. How many elements here? 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. That means in the two sets, number of elements are same. Then those two sets are said to be as equivalent sets. We denote equivalent sets by A to B. A equivalent to B, B equivalent to A. So observe here up to now 4 different types of sets I told. So first one is finite set. Finite means if a set contains limited number, countable number of elements, then that set is called finite set. If a set contains uncountable number of elements, then that set is called infinite set. Next, equal sets. Equal sets. If two sets are having same elements, then those two sets are said to be as equal sets. Next, equivalent sets. If two sets contains same number of elements, then those two sets are said to be as equivalent sets. Here one more thing you have to remember. All equal sets are equivalent sets, but all equivalent sets are not equal sets. How it is? Means, take here, these two are equal sets, and moreover these A and B are equivalent also. Why? Because how many elements here? 4. Here 4. That means number of elements in both A and B sets are same. If number of elements are same, then those two sets are said to be as equivalent as the definition. So equal sets are said to be as equivalent sets also, but equivalent sets we cannot, all equivalent sets we cannot say equal sets. Why? Because here number of elements are same, but elements are not same. Then if elements are same, then only we can say those two as equal sets. That's why one statement we have to remember as all equal sets are equivalent, but all equivalent sets are not equal. The next empty set. The next one is empty set. If number of elements in a set are 0, such type of set is called an empty set. That means A is a set which contains natural numbers in between 2 and 3. Natural numbers in between 2 and 3. What are the natural numbers between 2 and 3? Nothing is there. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5 and so on. And in between 2 and 3, what the natural number will be? Nothing. That means what will come under A? Nothing will come. So how many elements it has? No element. So number of elements, if a set contains 0 number of elements, then such type of set is called an empty set. We call empty set also as null set. And also void set also we call. we denote empty set by just empty brackets, nothing else, no any element in between these brackets, and also by symbol pi. So these are the symbols to represent an empty set. Then after that, singleton set. Singleton set. If a set contains only one element, then that set is called singleton set. That means, take one set B. Set B is a set which contains an element as a natural number between 3 and 5. Clearly it will be 4. A natural number between 3 and 5. So what is the natural number between 3 and 5? 4. Only 4. So how many elements here? Only 1. So if a set contains only one element, then that set is called singleton set. So clearly difference between these two. If a set contains no any element, then that set is called empty set. If a set contains only one element, then that is called singleton set. And the next, overlapping set. Disjoint set. Overlapping sets and disjoint sets. So I will take two sets. One is set A, another one is set B. The elements in set A are 2, 5, 7, 11. The elements in set B are 1, 3, 5, 7. Now, in both sets the elements are same? No. But some elements are commonly we can observe. 5 and 7. 5 and 7. That means if two sets have at least one common element, at least one, more than one, well and good, 2, 3, 5, 6 common elements, well and good. If two sets have at least one common element, then the sets are said to be as overlapping sets. Then after that, coming to disjoint sets, here also I will take two sets. One is A, one is B. Here the elements are A, E, I, O, U. Here the elements are 2, 4, 6, 8, 10. By observing, any common element is there in these two sets? No. If two sets have no any common element, then the sets are said to be as disjoint sets. At least one common element, overlapping set. No any common element, disjoint sets. Then after that, universal set. Universal set. That means A is one set, with the elements 1, 3, 5 and so on. That means the odd number set. B is one more set with the elements 2, 4, 6 and so on. That means even numbers. Even numbers. A is a set of odd numbers, B is a set of even numbers. Now one more set I will write. Observe, N is a set of natural numbers. What are the elements in A and also what are the elements in B? All the elements will be in this natural number set. A set which contains all the elements of the given sets is called universal set, bigger set, universal. So what are the elements in A? Will be here. What are the elements in B? Will be here. That's why this is called universal set. Universal sets are different. So in this situation it is universal set. And next is one more example. Take one set as A, I, O, U. Next one more set as set of consonant, set of vowels here. Then now one more set. I will take all the alphabets of all the English alphabets. That means A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Look here. Now what are the elements in V? Set V. What are the elements in set C? All the elements will be in set A. So A is called universal set. The next one more is the cardinal number of set. Cardinal number means how many numbers in a set. Number of elements in a set. How many elements in a set? Or number of elements in a set. And moreover, number of distinct elements in a set is called cardinal number. Number of distinct elements in a set. That means take one set A as 2, 3, 5, 7. Now how many elements in set A? 4 elements. So this 4 is called cardinal number of this set A. We denote cardinal number of set A as n of A. Number of cardinal number of A is equals to 4. We have to read like this. Cardinal number of A, cardinal number of set A is equals to 4. And one more example, B. 2, 3, 5, 7, 2, 9, 3, 6. Now observe. Count how many elements are there. 1, 2, 3, 4, 5, 6, 7, 8. So a cardinal number is 8? No. I told in the definition of cardinal number only. Number of distinct elements of a set is called cardinal number. That means different elements. So we have, if any element is repeating here, we have to rewrite. What is the rule of set? That is the rule of set we know. 2. 3, 5, 7. 2 repeating here, need not to write. And next 9. Next 3, 3 repeating here, need not to write. Next 6. So no any element are repeating here. All the elements are different elements. So distinct elements here. Now count. 1, 2, 3, 4, 5, 6. So how many elements here? How many distinct elements here? 6. So n of b is equals to 6. Ordinal number of b is equals to